Hello and welcome back to my channel. Today let's see polymorphism in a few lines. If you understood inheritance, well, polymorphism will be a breeze, just a breeze. So let's start with a class that we call animal. Okay. So what does an animal eat? Of course, an animal eats something. So let's say auto eat, but this is must be a public member function. Okay, so auto eat will return a const char pointer, const char pointer, return something, just something, and that's all. So animal is our base class. Now let's say that we have a derived class that inherits from animal, and this class is wolf. What does a wolf eat? What does a wolf eat? Well, a wolf, of course, eats meat. I've never heard of vegetarians wolves. So here I write meat. Okay, now let's say that I have another class still. A horse, for example. And a horse should eat grass. From what I know, should eat grass. What the fuck? Okay. So grass here. I'm not an expert in animals, huh? So I don't quite get the indentation problem here. Why? What's that? Okay. Okay. Sorry, huh? Now, let's say that our wolf inherits publicly. From who? From whom? From animal. And horse, the same. Publicly inherits from animal. So, what does that mean? Let's go on and see. Let's say that I have an object of type animal, an object of type wolf, an object of type horse. So A, W, and H. Now I want to manipulate each one of them via a pointer to animal. And I want to see what is the output when I try to call the member function. So let's say that I have animal pointer that I call animal ptr. Now let's call it animal, just animal. Okay, and let's make it point to initially just A. Okay, so animal. So what here is saying out, see out, what? See out animal arrow, because it is a pointer, it. Okay, so now what do? We make it point. Now we modify the pointer a bit. Let's say that the pointer no longer points to A but points to W, which is an object of type wolf. Okay, and then again animal, let's modify it to have it point to have it pointed to H. And let's call again. Cout in this fashion. Now it's almost completed. Okay, what do you expect the output to be? Well, what you have to understand is this. As things are at this very moment, we have no polymorphism. Okay, as things are here, who is commanding here? What member function is being called? I say to you that the member function being called is always the same, and it is the one from the class animal, this member function here. Why? Because who is commanding here is not the object pointed to, but the type that is handling that pointer. That is handling that object. Okay, so here who commands? Animal commands. And here too, who commands? Animal commands, which is our pointer to animal. So if we go back and compile, this is what we get. Something, something, something. In order to modify this behavior and let the object be the one who has priority, I just need to add a simple keyword here in the base class member function, which is virtual. Okay, now with this simple keyword, let's see what happens. Look, now the priority is given to the object that is being pointed to. Okay, this is the beauty of polymorphism. In order to help also the compiler to debug, I just add here another keyword. What does this keyword say? It says, look, this member function in this derived class here is meant to override a member function of a base class with the same signature. Okay? Now, if I had to, for example, modify here the signature, I would get a compiler warning. Okay? It is marked override, but the signature is not the same. I wouldn't get this warning without the override keyword. Huh? Okay, I wouldn't get it. So this was one important thing that we had to say. And well, we could also, yeah, I think that's all for today. That's all for today. Thank you and bye.